4.7 for geometry students here, using isosceles and equilateral triangles. So as we go through this here, we're going through some features of our isosceles and equilateral triangles that are going to be important. If you know a triangle's isosceles or equilateral, there's things you can automatically mark that will help you solve them and help you be able to find out missing pieces of information about them, okay? So we have some vocab here today, and I have to stress these are specific for an isosceles triangle, okay? Just like the other day in hypotenuse leg, we went over the hypotenuse in a leg, and those words were specific for a right triangle. So today's are specific for an isosceles triangle. So I drew an isosceles triangle in the margin, and I want to stress to you because it's so often that people, if I say isosceles, they want to put the one length on the bottom and always put the matching ones up the top. Just remember, an isosceles triangle can be drawn any way as long as two legs are congruent, okay? And that's our first one. The two congruent sides are the legs. So I like to mark them congruent because that's going to help us, and then these are both a leg, okay? Remember, the leg on a right triangle, they did not have to be congruent, but the legs on an isosceles triangle are the congruent sides. So as soon as you know leg, you know there's two of them with a matching number. Okay, we have a vertex angle, and this is an angle formed by the two sides, or I should call them legs, okay? So right between the two legs is the vertex angle, okay? And there is one and only one vertex angle. The third side of the isosceles triangle is the base, okay? And I want you to make sure you know it is what it is, a base, but you do not have to set it on there. Sure, this one looks like the base is on the bottom, but you don't have to have the base on the bottom. It's just the side that doesn't match the other two, okay? And then we have the base angles. These are the two adjacent or touching, right, angles to the base. So these angles down here that touch the base are your base angles, and there are two of them, right? There are two of those base angles because there's two angles that touch the base. Okay, super important vocab, because if I use any of those words at any time, you need to know, like vertex angle, there's only one. Base angle, there's two. Legs, those are the congruent parts, okay? So it's important that we know that vocab. All right, so let's talk about what these base angles do. We have two theorems, but if you notice right away, and just looking at their names, we have a base angles theorem, and then we have the converse of the base angles theorem, okay? So our base angles theorem says if two sides of the triangle are congruent, then the angles opposite them are congruent. So we follow them. They kind of point down here. That means this angle, follow this one, and this angle are congruent. Angle B is congruent to angle C, okay? If I put this in a proof, this is what I write. If legs, then angles. Okay, it's just a quick reminder to me. If I have two sides, then I have two angles, okay? So in the next theorem, it's just the converse. And we remember from chapter 2, converse just flips our information. This time it says if I have two base angles congruent or two angles congruent, then I follow them and the two sides opposite them will be congruent. So if angle B is congruent to angle C, then AB is congruent to side AC. And again, if I put this in a proof, I'm going to write if angles, then sides, okay? All right, let's go through. Just a minute, dropped my stylus. In this triangle FGH, FH is congruent to GH, so they marked it, right? Name two congruent angles. Again, let these point you to them. This one points over here to G. This one points over here to F. Okay, so it's the angles they're kind of pointing to. Never the angle between the two, but always the two that it's kind of pointing to, okay? Again, you could write that angle F congruent to angle G, that's fine. Just don't get the H in there because H is not the base angles. All right, page 2 already. Here's a corollary, which just means we can figure this out because of it. If a triangle is equilateral, all sides are equal, then it's also going to be equal angular, all angles equal. So if I see all sides equal, if I point them to their angles, all these angles are going to get marked as well. So we have this equal, and if it's equal angular, it will also be equilateral. So we can go back and forth between those. Okay, quick reminder, because this is something I just want you to know every time you see this. How many degrees in a triangle? 180. If all three are exactly the same measure, what will all three be? They will be. It's going to be 60. So I just want you to remember that if they're marked all congruent, you can automatically write 60 in all those. Now, does that mean we can automatically figure out how long the sides are every time? No. You can't figure out the side lengths because that's different for each triangle. But because angles are always 180 inside of a triangle, we can always know that an equal angular or equilateral triangle has angles of 60 degrees. Okay, so let's look at our example next. It says find the measures of angle R, S, and T. Okay, so I have triangle RST, and I notice that this is 3, this side's 3, and this side's 3. So that means that I have an equilateral triangle, right? So if I have an equilateral triangle, I know that all my angles are the same, okay? Now, if you're jumping ahead and you already wrote down the answer, that's fine. I'm going to kind of follow the way the book set this up. So we know that all my angles are also going to be equal, so I'm equal angular. So all of these angles are equal. So this angle plus this angle plus this angle, if I call it 3x, right? They call it 3, the measure of R. I can call it 3x equals 180, divide by 3, and I get 60. Again, if you just remember that rule, you never need to do the math on it. Just go straight to the 60, okay? All right. We have a diagram trying to find some values here, okay? So it says find the value of x. So I need to find x. It looks like it's on this bottom line right here. And I'm going to work off first this big triangle. All right, can't trace very well this morning. I notice that 1 mark, and right now for this triangle, 1 mark. Because it is equal angular, that's how they marked it, right? It's also going to be equilateral. Okay, so if KL over here is 8, what is JL down here? 8, right? They are all the same. So X is 8. Okay. Now let's switch triangles because we need to find the Y. Down here. Okay, this triangle right here now I'm looking at. That 8 still belongs to it, but notice I have 2 little marks here and 2 little marks here. So if 2 angles are marked, then I know that I have congruent. Okay, JML. I'm trying to figure out what they're saying here. JML is the one on the top, so MJL. MJL is the other one. Those two are congruent. So that means if I have 2 angles congruent, I have 2 sides. So I kind of follow those sides. J or 2y there is going to be the same as x, right? So LM is the same as LJ. All right. LM is 2y and LJ is x, which is also 8, right? Okay. So y is going to equal 4 because those two sides are equal. 8 equals 2y, y equals 4. Okay. Seems pretty straightforward, right, so far? Okay. So let's go to the top here of our 3rd page. Don't get too excited. I know 3 pages. I can ruin that real fast for you, right? Okay. I have a pattern in the quilt here shown, and it says, explain why ADC down here is equilateral. Okay. Definitely they did not mark it equilateral. They only marked 2 sides equal. But they also marked 2 angles equal. So if these angles are equal, follow them, right? Let them point you across. So across would be this one. It's marked. This one, if I go across, it's this one. Oh, I need to mark it, right? So when I mark it because of my base angles, then all of a sudden, I do have equilateral. So angle DAC was the same as angle ADC, right? So my base angles were congruent. So now I could mark so ADC is, I think it wanted you to say isosceles here because of 2 congruent angles. You have 2 congruent sides, but now you can mark all of them, right? So we're not going to worry about that. So now all of them are equilateral. Okay. Show that triangle CBA on the top is congruent to ADC on the bottom. Thinking I need to erase a little bit so I can see what I'm doing here. Okay, so I'm looking for the top here. I'm going to put that marking back on where I was, okay? And if I have those two lines marked, I can follow them to the angles. So I get an angle C here, but then I get an angle B up there, right? Okay, so how is the top triangle congruent to the bottom triangle? Well, I know ABC up here is congruent to ACB. That's what I just marked, right? ACB. And it looks like now, if I look at the two triangles, this one has angle, angle, side. This one has angle, angle, side. I realize there's more ways we can do that, but I'm going to go with the angle, angle, side. It's one way, right? I could probably mark my other angles and get a side angle side. I could get an angle side angle. Really a lot of ways there. No HL because it's not a right triangle, right? And I could probably do side, side, side as well. So lots of different ways to do that one. Okay. Come in here. I have copy and complete this statement over here. All right, it says if FH, that's this whole thing over here, is congruent to FJ, this whole thing here, what angles have to be congruent? So we follow there, right? They point across, so this one goes here, this one goes here. It'd have to be angle H congruent to angle J, okay? Let me get rid of some confusion in there. On 2, looking at FGK, this little triangle right here. It says F, and it's equal angular, so I can mark all my angles. It says FG is 15. What is GK right there? Well, if it's equal angular, it's also equilateral. So that means GK will be the same thing as FG, so it will be 15. Okay. All right. Bottom here. I don't remember if I put this in your notes, these pictures. So if I didn't, pause the video, copy these pictures down quick so you have them, because put them in here because I think it's important that you at least think about this and think about what we can do here. All right, so I have two triangles, and it says find all the missing angles in that triangle. All right, the triangle on the left. It's marked two sides congruent, so it's marked isosceles, right? And if two sides are equal, then two angles. So it points to my two angles that are equal. So if this is 50, this is 50. If I know the two bottom, can I now find the top? Sure. 50 plus 50 is 100. 180 for any triangle. So subtract the 100 we've already used, and I'm left with 80. All right, maybe I'm not to scale on that picture. I'm a terrible artist, okay? But hey, at least we know how to do this, right? So don't forget, this is what I would call my vertex angle up here, the one that's all by itself. And then these 50s would be the base angles, the two that are the same, right? The base angles will always be the same, two of them that match, and the vertex is by itself. The only way they'd all three be the same number is if it's equilateral, right? Okay, next one over here. Isosceles again, my angles point to congruent angles, but I don't have those. I only have the vertex angle. So if I have a vertex angle and it's 30, I can do 180, and I used up 30. That leaves me 150. What do I have to do with that 150? Well, I have to split it equally, right? Because it's split between two equal angles. So it looks like I get 75 for both of those, okay? So in an isosceles triangle, you only need one angle, and you can solve for the rest, okay? All right, now, I have your homework here already, page 267 to 268, 3 through 17 all, 19 through 25 all. You're welcome to stop at these notes and such and go do those. But you also could watch a little bit longer, and I'm going to do some examples because these notes seem pretty easy today, and they are. It's pretty straightforward. Isosceles triangles, two equal sides make two equal angles. Equilateral, all equal sides make all equal angles. Pretty Pretty easy stuff. But sometimes when you get thrown into a problem, something that uses algebra and stuff, it's not as easy as it was just in the notes. So if you feel like you got it, I can't stop you. Stop the video and go do your homework. But if you're getting stuck on the homework, come back and watch the last part of the video because I'm going to go through and do some examples, okay? So I have examples through your notes. They're on the, flip the page over, you're going to see them. Decide if you want to join us or not, okay? All right. So on this first one, I see that I have angles marked, and earlier in the chapter I would have said, okay, let's add all the angles together to 180. But let me show you one little problem. This one has a y, and these have x's. That's not going to work very well, okay? I'm going to tell you right now, we don't really want to do a system of equations if we can avoid it. We did a few of those earlier this chapter. So stop and say, well, what kind of triangle is it? Well, it's isosceles. If two sides are equal, two angles. Let those sides point you to the two angles. Whoa. That one, and then this one points you, wow, I keep bumping the eraser. This one points you over here, so this one. Okay, got to move this somehow. Okay, that means I have two equal angles. My base angles are equal, right? And that gives me a setup that thankfully only uses the x's. So I can do 3x minus 11 equals 2x plus 11. Solve in here. If I add 11 to both sides, it would almost look like they were going to cancel, but not when I add. I get 22. Subtract 2x, and I get x equals 22. All right, so keep that in mind. Oh, wait, I still need a y. What am I going to set 2y equal to? There's nothing I can because it's all by itself. I can plug back in my 22. 3 times 22, I don't know if I can get this to right up here. 3 times 22 is 66, minus 11 leaves me 55. Okay, over here, 2 times 22 is 44, plus 11 is 55. All right, now I can add my angles together. I can say 55 plus 55 plus 2y equals 180. That gives me 110 plus 2y equals 180. Subtract 110, 2y equals 70, and y equals 35. Okay, so using my rules, but plugging back in, things like that. So a mixture of my rules. All right. So number 2, I've got isosceles triangle, right? So I can come over here. This angle is equal to this angle. Do I really want to set 3x equal to y plus 7? 2 variables, 1 equation? Not if I can avoid it. Wait, it's a right triangle. I've already used up 90, right? Which leaves me with 90 on these other 2 angles. And those angles are the same. So if I take 90 and I divide by 2, all right, both of those angles are 45. I've got 2 separate equations. I don't have to do this. So 3x equals 45, x equals 15. Y plus 7 equals 45. So y equals 38. There we go. That one worked better. So same idea from 1 and 2, but because of the information given in different ways, I use different methods. And that's something to keep in mind. It's not always the same thing every time. Okay? Speaking of, it's not always the same each time. Let's look at this one. I have an isosceles triangle again. And this angle over here is x minus 2. I have this outside angle is 3y. Well, I definitely want to avoid that while I'm working with my x's. So I know those are 180, but I don't really want to do that. Wait. 2 sides are equal, 2 angles are equal. So if this over here is y minus 2, this over here is also, I'm sorry, x minus 2. It's not y. Oh, look, everything in my triangle is all x's. And all angles in a triangle add up to 180. That's what we can do this time. So see another method again. So I can do x minus 2 plus x minus 2, right? Those are 2 of my angles, plus 4x plus 10 will equal my 180. Okay, so a different method. 1x, 1x, 4x, that makes 6 x's. -2, -2, plus 10, so -4 plus 10 plus 6. Subtract 6, divide by 6. I need my calculator, just because I am not feeling the division today. How about 29? Okay. All right, we've got the x. How do we get the y? Do you remember earlier I said these two together equal 180, so 3y plus x minus 2 equals 180, right? All right, I don't want that x. Let's plug in that 29 for my x. 29 minus 2 is 27. All right, so 180 minus that 27 is 153. Divided by 3 is 51. Okay. All isosceles triangles, but 3 different methods depending on how the information. Okay. So always look at your example and say, how can I use the information I have? Okay. Let's look at a couple more. It's looking more and more complicated, isn't it? Okay. Keep one shape at a time. Okay. I'm going to come over here. Isosceles. Angles are the same. I peek at those angles. Oh, look, they are both in x value. I can just set those equal to each other. So, 3x plus 10 equals 5x minus 10. Subtract 3x. I know I keep changing how I'm moving things, right? More than one way to solve an equation. Just make sure you take your steps one at a time. 2x equals 20, x equals 10. Okay. Still have to solve for y. So I have this y that's over here. And it's on an isosceles triangle too. So that means this angle and this angle are the same. Okay, I'm going to plug in my 10 from earlier. 5 times 10 is 50, minus 10 is 40. 3 times 10 is 30, plus 10 is 40. Good, they should be the same. So on my red triangle, if I add my 40s, I get 80. If I subtract that from 180, I get 100. So this angle right over here is 100. Well, on the other side of it, this little angle right here, if I do 180 minus 100, because think about it, these angles, I have a 100 here, and I'm looking for this one right here. They make 180, so that's 80. That means if this side's 80, so is this side. So 4y is going to equal 80, and y equals 20. Okay. All right, number 5. Another isosceles triangle. I follow my congruent sides. This angle is congruent to this angle. Well, I don't have something marked in both angles, so I can't just do side or part equals part like I've done before. But if I put this 2x plus 11 over here, everything in that top triangle, all the angles are all marked and they're all with x. So I could set them equal to 180, right? 2x plus 11 plus 2x plus 11 plus x minus 2 equals 180. Okay, so I have 2x plus x, that makes 5x. Positive 11 minus 2 makes 20. Subtract my 20, divide by 5, x equals 32. Okay, on the bottom, to solve for y, all right, this angle is y. This angle would be the same because of my isosceles triangle, so I could label that one y. I'm just going to use the bottom triangle by itself. How about y plus 142 equals 180? Okay, 2y plus 142 equals 180. Subtract my 142, and y equals 19. All right. Number 6. Isosceles. This angle equals this angle. This angle equals this angle. And that one has a y in it, and nothing else does. So I don't really want to do anything with that one. All right. Over here, okay, this is going to be fun. I'm just going to call this big angle A, right? It's a vertical angle, and they're the same, right? Okay. So kind of, I don't know if this, okay, over here on the left side, I have an angle 2x plus 25, or minus 25. I should probably get that right. And a 2x minus 25 plus A equals 180, okay? On the little triangle on the right, if the bottom is x plus 5, its matching angle is going to be x plus 5. And I add A to it, and I get 180. Okay? If I subtract A on this side, on both triangles, okay, that means both of my equations has like 2x minus 25 plus 2x minus 25 equals 180 minus A. X plus 5 plus x plus 5 equals 180 minus A. If those 180 minus A's are the same, we know we can substitute, right? That means that because these two sides, this part over here of the equations are the same, then the other parts have to be the same. So I really get this equation that says 2x minus 25 plus 2x minus 25 equals x plus 5 plus x plus 5. Okay, so they really become equal. So on the left side, I get 4x minus 50. On the right side, I have 2x plus 10. And I'm solving for x. Subtract 2x. I get 2x minus 50 equals 10. Add 50. 2x equals 60. Divide by 2, and x equals 30. Okay. Just so you know, I'm not going to throw one of these at you on a test or quiz, but it's kind of good to kind of get some more algebra skills in here and figure some of this out. Okay, so we did get x equals 30. We still have a y up there. If x equals 30, this little angle down here is 35, and so is this one up here. And if I look at these together, I know that these angles here together equal 180. So I can do 35 plus my 9y plus 28, and it's going to equal 180. So I get 9y plus 35 plus 28 is 63. Subtract that 63. 9y equals 117. Divide by 9. And y equals 13. And I just went, what, up a page? Y equals 19. 13. Sorry, 13. Okay? All right. A little bit tricky, but it works. All right. Changing it up here. So you have a couple in your homework that say find the perimeter of the triangles. When it says this, I want you to be careful. I want you to find a number, okay? I don't want you to say, oh, well, it's 7x minus 16. No. Don't just add those. Actually find a number, which means you need to solve for your variable and then plug it back in, okay? So on this first example I see base angles congruent, so I let them point to the congruent sides, okay? So I can set 2x minus 1 equal to x plus 4. So I can solve for x here. So x minus 1 equals 4, add the 1, x equals 5. Okay. Well, that doesn't give me my perimeter yet. What I need to do is plug it back in. So I come up here, 2 times 5 minus 1. That's 10 minus 1, that's 9. Over here, 5 plus 4, that's 9. Should they be equal? Yes, those legs are the same, right? So now for my perimeter, I can add my sides. 9 plus 7 plus 9 equals 25. And it looks like we're in feet, okay? So I had to do some work to find each side's number, and then I can add the numbers together, okay? All right, so on 18, again, base angles, which makes these legs the same. So again, I can do x plus 6 equals 3x plus 2. Put my x's together. Subtract my 2. Remember, to move across that equal sign, you have to do the opposite operation. Divide by 2, and x equals 2. Plug it in. 2 plus 6 is 8. 3 times 2 is 6, plus 2 is 8, and I'm ready for my perimeter. I'm adding my sides, 8 plus 12 plus 8, and I get 28. It looks like it's going to be in inches. All right, last one. All my angles are the same. Equal angular means it's going to be equilateral. All the sides are the same. So I'm going to set them equal. Do I set 3 things equal to each other? Never. I can only use one equal sign at a time, okay? So here's the choice. You choose which 2 sides you want to use, okay? It doesn't matter. They'll all come out the same. Oh, you want the ones with the small numbers, right? 2x plus 3 and 4x minus 5. All right, if you want. Your choice. So I get 3 equals 2x minus 5. Add 5 on both sides. And x is going to be equal to 4. Plug it in. Where? Everywhere, right? We want all the sides. 4 times 4 is 16, minus 5 is 11. 2 times 4 is 8, plus 3 is 11. 7 times 4 is 28, minus 17 is 11. Okay, you're right. Did we have to plug it in each one? We didn't have to, because they should all come out the same, but at least when we plugged them in, they did. We must have done our math correct, right? So 11 plus 11 plus 11 for my perimeter is 33. All right, one more example. It's a proof. We gotta love the proofs, right? All right, here we go. Given FG is congruent to FJ, mark it in your picture. HG down here is congruent to IJ, mark it in your picture. We're trying to prove HF is congruent to IF. Interesting. What are we able to mark? Aha. If we look at this big triangle, okay, look at the big triangle right here. If we just marked that their legs right here are congruent, what else are congruent? Angles, right? So on those little triangles now on the side that have the yellow lines, we have a side angle side, okay? So we can use side angle side to prove the triangles, and then think about back from last section, corresponding parts of congruent triangles are congruent. We can now prove those legs are, or those other sides, right? So FG is congruent to FJ, that was given. It gave us a pair of sides. I'm going to actually erase everything I marked in here so we can see what we're using when, okay? So we use these givens, okay? That means if those sides are, that these angles down here are. Is there any confusion at those angles? No. So let's just call it angle G congruent to angle J, okay? So we have a set of sides, we have a set of angles already, right? Then they had HG congruent to IJ, that was given, right? Which is a set of sides again. So by the side angle side, we need to name those triangles. Okay, if I start at the top and go FGH, triangle FGH, it's congruent to triangle FJI by side angle side. And then, from what we said earlier, these two sides, FH, or HF and IF, that's what they called them, are congruent. And the reason is corresponding parts of congruent triangles are congruent. Okay? Thank you to all of you that stuck with me through these examples. I'm hoping I'm talking to at least one of you.